In video 13.3, we discovered the sum formula for adding up n terms in a geometric sequence was the formula Sn equals g sub 1 times the quantity 1 minus r to the n all over the quantity 1 minus r. Then in 13.4, we discovered that the limit as n approaches infinity of a geometric sequence was equal to 0 as long as the ratio, absolute value, is less than 1. Let's write that out so we're sure that that's what we're talking about. Okay, good. Today we're going to put those two ideas together, and we are going to, this is our objective, we are going to add all the terms of a geometric sequence. So this is what we're going to do, and good news, you're not going to have to add them by hand. You'll have a formula. So you heard me right, we're going to take a geometric sequence, an infinite, so this is important, it will be an infinite sequence that goes on forever and ever, and you're going to add up all the terms together. So in order to do this, let's start out with a little exploration. Let's say that my sequence is the following. I'm going to take a first term of 5, multiply by 1/5, and take that to the n minus 1 power. So this is my sequence, and so the first few terms would look like this. You get the idea. Okay? So if I ask you to add up 5 of those terms, you'd get your calculator out and you'd put in 5 minus 1/5 to the 5th power, all over 1 minus 1/5. I'll do that work for you. You get 6.248. Nothing too unusual about that. If you add the sum of the first 10 terms, again, same, but with a power of 10, you get a little bit more, but not that much more. Let's go to 15, and so when we replace the power n with 15, what a funny thing happens is that we get 6.25. So let's go ahead and jump right up to 100 and see if we notice anything unusual. And so what happens is that it's stuck at 6.25. And so you could keep doing this if you didn't believe me and take it to the 1,000th power, the 10,000th power. But the idea is that when we get to a certain value, our calculators, because we don't have that many numbers to display, they truncate the number and they give us 6.25. So we're thinking that that's probably the sum of the infinite sequence. Okay? So we're going to go ahead and present the formula, and it's the last formula for chapter 13. Okay? And it says that if you have to add up an infinite number of terms of a geometric sequence, provided that the ratio is between the values of 1 and -1, the infinite sum formula is that you take g sub 1, the first term, and divide by 1 minus r. Okay? It's funny they leave the easiest formula for the last of the chapter, but it really is that easy. Now if you're wondering, how can we go from, let's go back to this formula. How can we go from one for n terms that's got this much going on to one with an infinite number of terms to be this easy? Well, let's think about that other formula, which says that we take 1 minus r to the n over 1 minus r. And if I look at r to the n as n goes to infinity, this becomes 0 because the ratio is between -1 and 1. Okay? So hopefully this makes sense, how we get from the sum of n terms to the sum of all of the terms. Okay, one last example I want to show you that this formula works when the fraction is between -1 and 0. So let's look at this geometric series. And the way you notice that you're adding an infinite number of terms is that you'll see ... at the end, and there won't be a last term. And so this, we're saying, let's find the sum of an infinite number of terms. So we're going to take 9, the first term, and divide by 1 minus the ratio, and this is important, this time you're subtracting a negative, so you get 9 over 5/3. when you bring this up and flip it, you get 27 over 5. And so that's the sum. Pretty easy formula. I think you'll do great with it. See you in class.